split.
So that continues to the next page. So all the remaining goes into the next page, so it only shows 9 objects per page.
Okay.
So that's the view relation and works for every object, every diagram. And the next is the conversion routine, which is...
Does it want to show this now? Okay.
You want me to demonstrate this live?
No, it's okay.
Okay. So the next one, visualization page 2, we are coming into the conversion routine, and normally is going to talk about this one.
So the conversion routine basically runs a recursive algorithm.
For that, that's
It basically runs a recursive algorithm, and at each iteration it decides whether to do transform analysis or transaction analysis. And so if it is transaction analysis, meaning that like branching, they will do recursive analysis again on each of the branches and the input and output until transform analysis is done. And so so you see here, this is like a transaction-driven system. So it has 2 branches, and it starts to branch at a dispatch node, and it goes back in the collect node. So so after the algorithm is the conversion algorithm is run, it's gonna.
Yeah, it's going to be on a few different pages because it couldn't fit on one. So the next 3 screenshots actually are composed. This is the dispatch node. Go ahead.
The gray node is actually the byproduct of the conversion routine, but I intentionally left it in just so it's clear like what kind of analysis is done on what level. So
now this is the input screenshot of the input, right?
right, and you see at the top level a transaction analysis is done because it says
The mouse doesn't really move.
okay, there's no mouse. So at the top level it says transaction, and then so after the transaction it comes the input, output, and process branch, and then under this branch another the same algorithm is run on each of the branches. So so in the end you arrive at transform.
What do you highlight for the blue one?
The blue is the actual node. And this one is
okay.
Like it should be removed, but it's trivial to remove them. But I just leave it in. So
See, the name of this node, the blue one at the bottom, is branch 1. If you go back, you can see where branch 1 lives, which is the very top. Branch 1 and underneath is branch 2, and you got 2B and you got 2C.
Okay.
So then that's going to be easier to.
right, and also there's a diamond for the branches, and
Yeah, this for dispatcher, right?
yeah, the dispatcher.
Okay.
And it's very easy to use in the program. You just have to put a worksheet in the focus, and then you just click a button to apply the conversion. Okay, yes, that's it.
Okay, so these are the team members for the group 3. They're all listed. This actually tool, you can use it free of charge if you give us a good review. Let's see, we can go, if you have any questions, actually here's the working version of the application, and not certain if anybody has any questions.
What database is
We're using a built-in database into the C# that comes along with the C# environment.
This is text file or this is access with a SQL Oracle? I don't know.
Let's see. MS SQL, but it's built in. It's not the one. You don't need a server to run it.
It's a data file.
Is the Visual Studio what version?
2005.
2005?
Yes.
And how actually you store it? I don't know, for example, we use the network to for the known object in the database. How do you do this?
Well, we have
The drawing is done on the fly. It's using the .NET graphics library.
And how does what way is done? Use a function from .NET function?
Yeah, it's a .NET function. It's documented on MSDN. It's like a draw polygon function and draw rectangle, like few rectangles. It's all in .NET.
Oh, here it is, the database. Okay, so that's all the features that we have. If you close this and come back tomorrow, you can continue working. If you'd like to print it, you gotta take a snapshot of it. Any other questions?
Since you said for class hierarchy you have only one relation, inheritance, right?
That's correct.
But we have other relations, as you know, composition.
This is really the scope of the assignment. So what we did was we only saw the need at this point for the hierarchical arrows in this type of diagram. So all the other arrows actually disabled.
I mean, we cannot have composition relation.
Composition goes in a class diagram, right? Hierarchical diagram shows only the hierarchies of a class. So if you take the composition and that's called aggregation, goes in a class diagram where you show the relationship between classes. Whereas if you take the hierarchy,
Which composition are you talking about?
We have the composition relation for class hierarchy.
Yeah, but I didn't ask you.
Oh, no, I'm just asking.
Okay, you ask.
Yeah. And we can have the dictionary for each object, right?
For every instance, we do have data dictionary.
I mean, I cannot have the data dictionary of the whole project.
It was really easy to do, but we don't have it. Actually, the scope of the assignment really asks to be able to display the information, so we are actually able to do that, but it will be really easy to spin. We are constantly spinning through these. Every worksheet contains a set of instances. We have an instance handler, and in the instance handler there is concrete instances and ADT instances and SM instances and relationship instances. So we can keep spinning through all these things and pick up information. Currently it only displays single instance. It wouldn't be hard to enhance this at all.
And I have a question about the diamond that you used. How did you figure out that you have to use that diamond at that place? I mean, when you convert the diagram, you have so many, for example, no. How do you know that you have to use diamond? Because you know, we use diamond when there is or this and or that. I mean, how do you figure out that you have to use diamond with these information?
Oh, you're talking about the conversion routine.
All right.
Yes.
Actually, I went to the algorithm and check where the branching occurs the most. You go back to the
Yeah, here's
Oh,
the.
yeah.
I don't know if you guys saw it, but we are running it live.
yeah, because I mean this.
Here's the dispatch.
One of the algorithm is to one of the sub algorithm is to check which node has the most branching factor, because it's calculated mathematically, and if that node has the most branching, then it's going to branch from there, and the diamond is going to be added under it.
You mean anytime you have so many nodes, you have that diamond?
Now, once you have branch,
Once you have a branch,
Anytime you have so many branches, you have the diamond. What is that for that? For the diamond?
example, yeah.
But it's not for all.
No.
Maybe you have so many branches, but you don't need that diamond.
Actually,
Maybe for
Well, because you have so many different branch, but they are standalone classes. So once you pick up one,
Exactly,
then
yeah. Maybe this happens, maybe that happens, right?
yeah, yeah.
That's my question. How do you figure out that from this information?
figure out where to put the diamond.
Yeah, exactly.
The mathematical function that calculates the branching factor. Just like a ad hoc function that I made that check where the branching is the most branching occurring.
so in this diagram, it actually only occurs here, so it was easy to do. Actually, only design the.
I have. Do you used to have the PowerPoint for that? first presentation.
Do we have